morning, students.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. My voice is clear. Is my voice clear?
Yes, sir.
Okay, right. So I will start the class now. Those who are not attending the classes, I will give the link, YouTube link. So you can also see in that link the whichever you are missing topics, you can easily listen by clicking on that link. Okay, and also share that links to your friends, those who are not available today. That is also good. Okay, so we have completed up to 3.4. That is, what is that 3.4? The comparison between a different power amplifiers, class A, class B, class C, and class AB. Correct or not? So now I want to introduce different distortions present in power amplifiers. So what are the various distortions, various types of distortion present in power amplifier circuits are amplitude distortion, frequency distortion, phase distortion, crossover distortion, out of band distortion, and in band distortion. So there are six distortions present in the power amplifier circuits, and they are amplitude distortion, frequency distortion, phase distortion, crossover distortion, out of band distortion, and in band distortion. Okay, so if you've seen the what is distortion means, we already discussed that it is the shape, it is shape which is the output shape is different from your input shape. So then you can call it as a distortion. So if you are the shape, it is the difference or distortion is present in the amplitude or in the voltage levels, signal strength. The signal strength, if it has the distortion, then you can call as the amplitude distortion. So in the amplitude wise, if the distortion is present and it is output of the power amplifier, it will occur, then it can be called as an amplitude distortion. So if the distortion is present in the frequency range, the amplifier output, the power amplifier output is frequency is somewhat distorted, then you can call as a frequency distortion. That means it is difference in the frequency of the input signal. Is it clear? If the difference present in the output of the power amplifier is different from a amplitude of the input signal of the power amplifier, then you can call as the amplitude distortion. So if the frequency of the output amplifier is different from the input of the frequency of a power amplifier, you can call as a frequency distortion. So phase distortion is also same like that. So phase of the signal, output signal is different from the phase of the input signal. So, and that means you have there is no much difference between the amplitude and frequency, but it is only concentrate on the phase where the phase is different from your input side. Okay, so this is the phase distortion. So crossover distortion is the basically it is mainly present in the class B push-pull power amplifier. Okay, so in a class B push-pull power amplifier or class B amplifiers have a crossover distortion. The class A, it is not having any crossover distortion, but in a class B we have a crossover distortion which is much present in the power amplifier circuits. Why? Because it is having a two transistors, NPN transistor and PNP transistors. Two transistors. So whenever the first transistor is on, other transistor is off. And the second same thing, if the second transistor is on, first transistor is off, like that. So if the something, if you are on to off or off to on, what will happen? Some switching is present. So if the switching is fast, then there is no distortion. If the switching has some delay, some distortion is present. That distortion you can call as a crossover distortion. That means whenever the signal is crossing from positive half cycle to negative half cycle, or negative half cycle to positive half cycle, what will happen? It is instantaneously, it is quickly, it is not changing from positive half cycle to negative half cycle. It will take some time. So that time you can call as a delay. The delay is present in the output signal. So that delay signal, if it is there, you can call as a crossover distortion. Okay. So these are the crossover distortion mainly present in the class B push-pull power amplifier, where you have required two transistors, NPN as well as PNP transistors. Next one, we have an out of band distortion and in band distortion. These two are present due to the over modulation of the input signal. Okay, it is due to the over modulation of the input signal which is there because of the non-linearity is present in the power amplifier circuits. Okay, so basically it is due to the non-linearities present in the power amplifier circuits and affects over modulated signals. It is over modulated signals. That means modulation is greater than 100%. You know in the communication what is the modulation and over modulation and under modulation and a critical modulation. If the what is that modulation index is greater than 1 or greater than 100%, you can call as a it is a over modulated signal. So due to it is non-linearity is present in the power amplifier circuits, we can see in this type of cross out of band distortion as well as the in band distortion. Okay, so just remember this distortion and as well as the definitions. So they will ask what is the amplitude distortion. So you can say simply the distortion is present in the amplitude of the output signal of the power amplifier is not same as that of the your input side signal. Then you can call as a amplitude distortion. So frequency of the output signal is not same as that of the input signal, and this type of distortion you can call as a frequency distortion. Okay, so distortion is you can't avoid in power amplifiers, whereas voltage amplifier you can easily avoid because it is a small signal amplification, whereas in the power amplifier we require the strength of the signal you want more, so distortion is also present but you can't eliminate completely. Okay, so this is the definitions of distortions. So next we will go for a circuit of class A power amplifier with resistive load. Okay, so how the class A power amplifier will work with the resistive load? There are the two types of loads you can apply for a class A power amplifier. So resistive load second one is the transformer load. So efficiency is increased due to in the transformer load, whereas resistive load the efficiency of class A power amplifier only 25%. So how it will be only 25% means you can see here. So what is a class A power amplifier? The class A power amplifier is simply it is a voltage amplifier only. So class A amplifier is same as that of your CG amplifier. Okay, your CG amplifier. So what is CE amplifier? You know well. So what is the CE amplifier? This is the CE amplifier. See in the circuit diagram, all of you. So draw it in your notes, running notes. So it is very important. Class A power amplifier with resistive load or transformer they will ask in the exam paper. Okay. So what is that? You can see here the same as that of class A power amplifier is same as that of your voltage amplifier or CG amplifier. So because what is the major difference between your CE amplifier and this class A power amplifier is that the transistor. So if your normal BJT, normal transistor, if you are using here, then you can call as the CE amplifier. If the power transistor, here the transistor Q is power transistor, then you can call as a class A power amplifier. So what is the difference? You know very well. What is the power amplifier and what is the voltage amplifier? So here the power BJT has beta value. Power BJT or power transistor has beta value less than 50. Okay. So the greater than so in this you can see here, so the resistors R1, R2 and RE will provide say biasing purpose. And the RL is the load. RL is the load. RL is the load. CE is the bypass capacitor. Cin is the input capacitor. The signal you can hear, the input signal you can even hear the AC signal. Okay. So what is this? The series fed class A power amplifier with resistive load RL. The transistor used here is operating in a common emitter configuration CE mode because it gives the largest power gain of all three possible connections. What are the all three possible connections? CB, CE, CC. Okay. In this CE configuration getting you will get a higher power gain because average voltage gain, average current gain. The multiplication of voltage gain and current gain you can give the power gain. So power gain is 50 into 50, that means 2500 watts of power. So 2.5k kilowatts of power you can easily deliver by CE mode. So that is the reason the class A power amplifier you will see the what is that, you can see the more energy, more power. So that is the reason they are using C configuration in a class A power amplifier. And the resistors R1, R2 and RE form the biasing and stabilization purpose. Correct or not? We already discussed what is the biasing, what is the stabilization, what is the beta. Okay, everything you have learned. Okay, stabilization factor, everything. So R1, R2 and RE provides the biasing and stabilization. And the electrolyte capacitor C in used as a couple the AC signal voltage to the base of the transistor. So Cin is used to couple the AC signal voltage to the base of the transistor. The entire bypass emitter bypass capacitor CA is connected to parallel with the RE to provide a low reactance path to the amplified of AC signal. So what is that means? It will provide a bypass capacitor bypassing. Now to bypass the what is that, you can bypass through this CE bypass the what type of signal you can bypass? So AC signal. So okay, AC signal it will bypass here. So and the output power will collect at the load resistor RL. The output power will collect at the load RL. So see this diagram. It is also very important. So if you see this load characteristics, load line characteristic, VCE versus IC output characteristics are load line. What is the load line? This is DC load line characteristics. So in the DC load line characteristics, if you see in Q is operating point. So in the Q is operating point exactly middle of the load line. The class A power amplifier, if you see the operating point, the operating point is exactly middle of the load line. So what is the load line here? This is the load line. So this is the load line. So it is middle of the load line. So Q point is exactly middle of the load line. So what is this? This is you can call as a characteristics. So characteristics of the transistor here like this, and the load line if you draw between this VCE versus IC, you will get the load line like this, and you can make the operating point at the exactly middle of the load line. That is the reason. So input signal, what is the input signal? It is here. Here the input signal. The input signal is the shape is same as that of the output signal. So it is, but it is amplified. Correct or not? Input signal is like this, and output signal also like the same thing. But what will happen? Here amplified. The signal is amplified because it is exactly middle of the load line. So that is the reason there is no much distortion. There is no distortion actually, you can say in the class A power amplifiers. So the conduction angle of the signal in the class A power amplifier is 360 degrees. You can see because of the Q point is at the middle of the load line. So what is the load line points at the at a x-axis, that is VCE. On a VCE you can have a VCC, and y-axis you have a VCC by RL. Okay. So how can we? This means, so it is in the DC operation. What will a DC operation? The VCC applied to the to the circuit without input signal. DC operation means without input signal, that is without AC, without giving this AC. AC equal to 0. The signal is 0, and you connect to VCC only VCC. What will happen? That is called a DC operation. So, and that characteristics you will get a DC low line characteristics. This is the DC low line characteristics. So, what is the zero signal current or ICQ? So ICQ equal meter times IBQ. So meter times the base of the input current, base input current. So, and corresponding zero signal current or current to emitter voltage is VCEQ. So what is the, how we will get VCEQ? VCEQ we will get in the characteristics of this, okay, and VCEQ equal to VCC minus ICQ into RL. So hence the Q point is defined as the VCEQ comma ICQ. So what is the Q point? Q point is our operating point is it's the coordinates of the VCE comma IC. So Q point is the VCEQ comma ICQ. Okay. So same thing in the AC operation. What is AC operation? With VCC, you can also apply signal in input AC signal. Then you can call as a AC operation. So in the AC operation, what will happen? The AC signal is applied to the base current through CN. CN, what is CN? Input capacitor. So what will happen? It will same as that of your amplifier. It will amplify the signal, and you are getting some output at this load. Okay, you can see the operation is same as that of CE amplifier. We already discussed. It is connected in CE configuration. What will happen? It is connected to the base of the transistor. Base of the transistor. What is the action of the transistor? It will amplify the signal. So it will amplify the signal. You will get the output. So what is the major advantages? You can see. So what is the major advantage is the circuit is simple and easy to design. So, and the load is directly connected to the collector circuit. Hence, the output coupling element is not required. This makes the circuit cheaper. So, it will complexity is less. The less complex and simple to design and implement, and also it has the cheaper. It is cheaper. It is also it is a cheapest of the all the other amplifiers. And what is the disadvantage? Major disadvantage is the efficiency is very small. It is only about 25%, and also output impedance is high. The output impedance of the circuit is high, so that is the reason you can't able to load the loudspeakers. Because the output impedance should be high, and that is the reason you can't load such as loudspeakers. Okay, and also some other thing is that it is also wastage of the power. So the wastage of the power in the circuit also there in the class A power amplifier. They are the major disadvantages. So what are the major disadvantages? Means first disadvantage is that lower efficiency, very lowest efficiency, about 25%. That means you are giving 100 watts of power, you will get only 25 watts of power. So that is wastage of power. 75 watts of power is wastage. So there is a power wastage. And the third is your output impedance of this amplifier is high, and it can't be load the loudspeakers such as small resistance loudspeakers or motors. So that is the reason. This is the advantage as well as the disadvantages of a class A power amplifier. So you can derive the expression for efficiency of the class A power amplifier. So what is the efficiency of the power amplifier? You can see here you can see that what is the percent of eta for a power amplifiers. We already discussed. All of you tell me general formula for expression for efficiency of the any power amplifier. Chipannamma, are you listening?
Yes, sir.
Yes, sir.
Sukanya, చెప్పు. ఏం రన్నింగ్ నోట్స్ లేదా? బుక్స్ లేవా మీ దగ్గర?
PAC by PDC.
పిఎస్సియా పీడీసీయా పీడీసీ బై పిఈసీయా?
PAC by PDC
PAC
into
by
100.
PDC, sir.
That
PDC
is
into
the
100, sir.
not the general formula. What is the overall efficiency of any amplifier circuit? V max minus V minimum into I max minus I minimum divided by 8 into
8
VCC into
8
ICQ.
VCC into ICQ into 100.
Into 100, sir.
Okay, so that is the formula you have to learn. That is the general formula for any expression for any conversion efficiency of power amplifier. So what is the Vmax? The Vmax can be concluded from this load characteristics. Okay, DC characteristics. So what is the Vmax? It is VCC. Vmax is VCC. Correct? Vmax maximum voltage you can apply is VCC. So what is the Imax? What is the Imax? Equal to 2 times ICQ. So what is the Imax? Imax is so ICQ in plus ICQ. So 2 ICQ. So next, what is the I minimum is 0. So V minimum is 0. So what is the values you can substitute here in this formula? You have to substitute this formula, these values. V max is VCC, V minimum is 0, I minimum is 0, I max is 2 times ICQ. So what will happen? So you will get this VCC minus 0 into 2 ICQ minus 0 into 100 divided by 8 into VCC ICQ. So you will solve this, you will get a 25%. So the maximum efficiency can be obtained from a directly coupled series fed class A power amplifier is only 25%, and this efficiency is ideal. So that means 25% is ideal. If you can, and the connected practical case, if you seen in the practical case, you connected in laboratory, you will not get this much also. That means it is the practically it is less than 25%. That means that is very less efficient. So if you connect in practically connected in laboratories, you will not also get 25%. It is only about 10 to 15% only efficiency you will get in the class A power amplifier. The efficiency is very poor, and due to large power dissipation. That means you are giving 100 watts, you will get only about 10 to 15 watts only. That means you are getting your loss of 80 to 85% energy is lost. That means it is produced in the form of heat. So that is the wastage of power. So that is the reason you are going for another type of configuration. What is that configuration? Class A amplifier with transformer load. So operation of class A amplifier with transformer load. So if you see in the transformer load, so what is the difference in the circuit? You can observe this. What is this? You connect replace the RL with the transformer. Correct or not? You are just replacing the RL with the transformer, and you connect a load, the loudspeaker. So this is the difference. So there is no much difference in the construction of a class A power amplifier with transformer load. Okay. So what is the reason to you are connecting this transformer? Easy to guess. What is that major advantage? Chapandi? The major advantage of connecting this transformer at the load of class A power amplifier is impedance matching. Due to the impedance matching, you can transfer maximum power from the input to the output. That means the output you are getting at the transistor will connect the primary windings of the transistor T2, and it is directly connected to the secondary windings of transformer, and it is directly given to the loudspeaker here. So that is much energy you are directly joined to the load. So this is the major advantage because of impedance matching. So that what will happen? This is the circuit in the load characteristics. You can draw it in your notes. This is load characteristics. So what will happen? What is that? What will happen? So it is getting more energy. It will transfer more energy. So in the DC AC operation, if you've seen, so if you know the operation of transformer, you will easily understood, because the output energy RL dash. What is the RL dash? Is the load resistance is n times n square times RL. So for example, RL is 5. RL is 5 ohms only. So if you are increase the more tons, N is the number of tons. So more tons means, for example, in a tons ratio. So N1 by N2 is the tons ratio. So N1 is the tons present in the input side, the primary winding. So N2 is the turns present in the secondary winding. So if the turns present in the input side is more greater than N1 is greater than N2, you will get the N square is much. So for example, N is 1000. So 1000 whole square. So 1000 is 10 power 6. So 10 power 3 into whole square, 10 power 6 into 5 ohms. 5 mega ohms. So 5 mega ohm means energy you can easily transfer to the your load resistor. So that is the only difference. Only difference is, so operation is same. DC operation of the C amplifier and AC amplifier, AC operation of the capacity power amplifier is same. So difference is that you have to increase the number of turns. So if your number of turns is more, so it will provide impedance matching. Due to the impedance matching, what will happen? It will transfer the maximum energy to the load. So what is the load here? Loudspeaker. So load is loudspeaker, and which has a low resistance, and it will a number of turns is increases. So that is that. What is that? You can call as a voltage up converted or down converted. It is up conversion. So it is due to the transformer up conversion will be done, and it will be transferred to the load, and you will get a maximum power transfer, and it is also not that much efficient, and it is only present 25 percentage to 50 percentage of efficiency only. So you will get ideally 50% of efficiency in the class A power amplifier with transformer load. So what is the advantage? It will increases the efficiency up to 50%. And the other advantage is you are connecting the transformer. You are connecting the transformer means you are getting a impedance matching. So power dissipation is less, and it will also provides a less power dissipation and impedance matching. So this is the advantages. Efficiency is increases to 50%, and you are getting the lower power dissipation compared to the class A resistive load, and you are also providing the impedance matching network. There is no external impedance matching network which is required here. So next is disadvantages. What are the disadvantages means? So first and foremost disadvantage is transformer, because the transformer is bulkier as well as it is costlier. So you are using a transformer wherever the circuits, whatever the circuits you are using means you have it will have provides a bulky as well as costlier effects. So this effects it improves the cost of the overall circuit. So it will improve the cost of the circuit, and that is the major disadvantage. And circuit complexity also increases compared to a resistive load. Correct or not? In the circuit point of view, if you seen the complexity, the class A power amplifier with resistive load has a components of R and C only. Here transformer is, so complexity also increases. So frequency response of the transformer coupled amplifier, what will happen is poor. Frequency response is poor. We have also seen in the coupling networks, RC coupling, transformer coupling, that frequency response, the peaks. So it will a major peak is present in the frequency response. It will not get inverted top shape frequency response. It has some peaks in the frequency response. So it is a poor frequency response, you can call. So these are the major disadvantages due to the transformer present as a load in the class A power amplifier. Okay. So and if you see in efficiency, it is also same thing. If you draw it this low line characteristics, and what is happened to the Vmax is 2 VCC here. You can see here the Vmax is 2 VCC and Imax is 2 ICQ, same thing. V minimum is 0, I minimum is 0. So substitute in the general formula. Substitute in the general formula. What is the general formula? This is the general formula. Percent of theta equal to V max minus V minimum into I max minus I minimum divided by 8 into VCC into ICQ into 100. So V max is 2 VCC, V minimum is 0, I max is IC2 ICQ, I minimum is 0. So substitute here, it is 4 VCCQ divided by 8 VCC into ICQ. So VCC ICQ, VCC ICQ cancel out. 4 by 8 means 1 by 2. 1 by 2 means 50%. So it is 50%. If you see here, there's a diagram as well as the derivation. So this is the class A power amplifier with the transformer load. Transformer load. Okay. Is it clear, all of you?
Yes, sir.
Is it understandable, everyone?
Yes, sir. Yes, sir.
So this is the class today. So what is the class A power amplifier? Tell me. Class A power amplifier అంటే ఏంటమ్మా?
The collector current flows at all times, sir.
Very good.
During the cycle of the input signal.
Conductor current means it is output current generally. So the output current
Yes, sir.
is what is happening? It is 360 degrees conduction angle. So conduction angle of the output current is 360 degrees. So what is the efficiency of a class A power amplifier with resistive load? Maximum.
25%.
Very good. So ideally speaking, you have a 25% efficiency. What is the practical efficiency?
Sir, less than 25%.
What is that practical? You can see. Less than means what? 10 to 15%.
10 to 15%.
15. Okay. Next, what is the efficiency of class A with transformer coupled?
50%, sir.
50%, sir.
Ideally 50%. So what is the practical? It will be only
30 to 50%.
25 to 50 only. Okay. So that is a maximum 50. It is generally it is 25 to 50 in the practical case. So in the, what is the class A amplifier? Which one have whether the class A amplifier has distortion? Whether class A power amplifier has distortion? Yes or no?
No, sir.
No. What is the reason there is no distortion present in class A? What is the meaning of distortion?
Sir, less efficiency. It has less efficiency.
So less efficient, okay, but distortion is present or not?
Sir, no distortion, sir.
So what is the reason? The reason is that it is a class A amplifier. Class A amplifier, in a class A amplifier, the conduction angle is 360 degrees. That means the output signal is same as that of shape of the output signal is same as that of the shape of the input signal. So if the shape of the output is equal to shape of the input signal, there is no distortion we can call. If the shape is different from your input side, then you can call as a distortion. So distortion is not present because conduction angle is 360 degrees, because the Q point or operating point is at the exactly middle of the load line. So it will swings complete cycle at the middle of the load line. So that is the reason in the biasing purpose you have to fix the operating point at the active region of the transistor. So active region of the transistor means at the exactly middle of the load line. So in the the operating point is operated in active region and exactly middle of the load line. So there is no distortion. There is no distortion because it will completely swings. Complete swing is present in the output side. Okay. So that is the distortion. Okay. So I will wind up here. So I will also share the link. Do share this link to your friends. That will help you much more. Okay, we will discuss the class B and the other amplifiers in the next class. Okay, I will end in this session. Thank you all.